So we are continuing dealing with Archies, three hinge Archies that are determinate. The essence, sometimes, most of the time, the need for Archies arises when one wants to reduce bending moment in a beam. When a system is arced instead of using a ordinary beam, bending moment reduces. If one sees most of the old architectures were arced, most bridges were arced because it reduces bending moment in the system just by arcing. And so there are also other advantages, aesthetic advantages of using the arc. So now we're going to deal with another 3-hinge arc that is loaded with a pointed load at a point 5 meters from point B, at a point 5 meters from the horizontal distance of RB to that point is 5 meters. At a point 8 kilonewton. If we want to get the height of, at what height is 8 kilonewton, we just apply 5 meters into this equation. We get L squared. We get the height. So to start, just like we did before, what we do is to take moment. We get reactions. The reactions is arrow. The first reaction we get arrow A vertical and arrow B vertical. Because we take moment at B, we get arrow A vertical, we take moment at A, we take arrow B vertical. Then we cut at the hinge, because at the hinge the moment is 0. So we had to cut because the hinge introduces flexibility, which means there's no moment, resisting moment there. There's no resistance moment. So we can cut at that point and still take moment at that point and transfer that moment as equal to 0. And it works out and solves our problem. So to start, let me now start getting reaction A. So to get reaction A, I say that total moment about B is equal to 0, I did before. So I have, because the span is 15, I have 15 arrow A vertical. Arrow A vertical. Arrow B, arrow A horizontal will not come in because it is at the same point and at the same level with the reaction B we're talking about. At the same horizontal level. So then minus the load. The load, 8 times the distance, which is 5, is equal to, there's no other load, is equal to 0. There's no other load that can generate bending moment there. So since there's no other one, then I will have that arrow A vertical is equal to 40 over 15. 40 over 15, arrow A vertical. We get 2.67. Arrow A vertical is equal to 2.67 kilonewtons. As simple as that. So let us think of getting RB vertical. We put that moment about A is equal to 0 to get RB vertical. The RB vertical, we have 15 RB vertical. With RB vertical turning this way, the load turns against it, minus 8 times. That's we're talking moment about A now. 8 times the distance from here to this 15, that's 10. 8 times 10, because that's the distance from here to here. See, the whole distance is 15 and this is 5. That is 10. It's equal to 0 since there's no other load that will generate moment. So we have arrow B vertical is equal to 80. 80 over 15. 80 over 15. Arrow B, that's 80 over 15, which is 5.33. 5.33 kilonewtons. That is RB. If you add the two, they will give you 8. That's vertical forces. Vertical, that's a check to check. If you add them, they should give you, the two of them are supposed to give you 8 to show that you didn't make a mistake. If it didn't give you 8, then if two of them didn't give you 8, then your mistake has been made. So since he gave us 8, if you can add the two, he gave us 8, that means we didn't make a mistake. Then so the next thing is to get arrow A horizontal and arrow B horizontal. To get arrow A horizontal, we cut the arc this way. We cut the arc at the hinge at point C. That's at the hinge. This is arrow B, arrow A horizontal. This is arrow B, arrow A vertical. ROA vertical is 2 point, was given at 2.67 kilonewton, ROA vertical. So there's no other load. So the distance of ROA horizontal from C, vertical distance is 2.5. Then this to the horizontal distance is 7.5, half of 15 for 2.67. So we take moment about C, about point C. So total moment at point C is equal to 0. We have 2.67 times the distance of this to C, that is 7.5. That's half of 15. Then the next load is minus ROA horizontal, and the distance of ROA to that point is 2.5. 2.5, that's the vertical distance. ROA horizontal. There's no other load. Look at it here. There's no other load. So it's equal to 0. So ROA horizontal is equal to 2.67 times 7.5 over 2.5. We get ROA horizontal. ROA horizontal, what is 8.01 horizontal. 8.01 kilonewton. That's ROA horizontal. Then to get ROB horizontal, the same way you cut the arc. ROB horizontal, look at ROB horizontal. ROB vertical, we got it to be, ROB vertical was gotten to be, 5.33 kilonewton. So the distance from here, the horizontal distance to that point is 7.5. The vertical distance to that point is 2.5 meters. And remember the load, and the load 8. Do you see now this side, when we cut C, on the right side, the load comes in. So, and the distance is, this is 5 meters. The distance of to the is 5. So from that distance, from this point 5 to the hinge will be 2.5. That's 7.5 minus 5. That's 2.5. So if we now want to get that, we say total moment above C now is equal to 0. This is C. So we have 5.5. We have 5.33 times the distance, that is 7.5. 7.5 is going to turn this way, but then minus to this point, that is 2.5 RB horizontal minus 2.5 times 8, that is distance, the horizontal distance of that two. That because the load, all of them turn against ROA. This is equal to 0. There's no other load that will generate bending moment. Then that means ROB horizontal. That means ROB horizontal. ROB horizontal becomes equal to 7.99 kilonewton, equal to 7.99 kilonewton. That's ROB horizontal. So we've gotten the whole reaction. In the reaction A, vertical, reaction B, horizontal, reaction B, vertical, reaction A, horizontal. The whole reaction has been gotten. Now the next is to we can calculate bending moment anywhere we want to calculate. Anywhere we want to calculate the bending moment on the arc. So if we want to calculate, we can start from A or start from B. Either at support A or support B. We start like, if we start from support A and take a distance of, let's say, 10 meters horizontally, so that we can meet up where the load is. If we take moment on that to up to that, we have the moment at the point, that's the point of that load, at the point of the moment at the point of the load to be, we have the moment at the point of the load to be, if we take moment at that point of the load, we have M at, let's say I give this point D, M at D is equal to, I look at this, I start from this side, I start from A. If I start from A, the RA will generate moment at that point. RA will generate moment, which will be RA times the distance from here to here, which is that is 10, which is RA is, what was that RA? We got RA vertical to be 2.67 times 10, because that is it. RA times the distance, look at it. Times this distance, this is the perpendicular distance, which is horizontal, then minus RA horizontal, what do we get RA horizontal to be? RA horizontal, 8.01, RA horizontal to be 8.01, so minus 8.01 times the distance, that's the height, to the, from here to the load, the distance from that height, which is 2.22. That's 2.22. 2.22. If you want to know how I got it, just put, this is the rise is 2.5. This F is 2.5. The L is 15. 15 squared. Then 15 minus the 10 meters. That is the horizontal distance. That's another 10 meters. You will get 2.22. This more MD, the moment at that point, because that's the only two loads. This and this, we have not reached to this load. This load, we're at the point of this load. So at this one point, it cannot generate moment. It has no distance at this one point. So we are starting from here. So these two are only the two that will come in to play a part. So at that MD, we got the moment at that MD to be 8.918, 8.91, so to speak, 8.91. It's about 8.91 kilonewton. That is that's the moment at this point. That's the moment at point D. Starting from A. If I decide to start from B, it's as simple as taking the same moment. If I want to start at B, if I want to start B, it will be the moment at D, starting from D, will be equal to RB vertical, which is 5.33, times the distance, which is, in this case, is 5, it's not 10, 5, then minus RB horizontal, where is RB horizontal? RB horizontal, I got RB horizontal somewhere. I got RB horizontal to be RB horizontal 7.99 minus 7.99 times the distance, to that point, that is 2.22 MD from that side gave me something, 8.9. That's why that shows we are correct. 8.91 kilonewton. Something. So that's how we got the reaction. We got the reaction at A horizontal, reaction at A vertical, reaction at B horizontal, reaction at B vertical. Then we got moment at the point of the load. We can get the moment at any point. The other one, we took moment at the point of the hinge, which we got to be 0, and that shows we are right. This time we move starting from a point support A, we were able to get moment at the point of the load. We start from point support B, we got the same value of moment at the point of the load. That implies we are correct. So this is how to calculate the bending moment all over the arc. Anywhere in the arc you want to calculate. Remember, the arc is a parabola, and this is the equation of a parabola, with which you will get used to get any of the vertical positions on the arc. So with that, you'll be able to get all the stresses in the arc